Okay, great. Okay, so first of all, thank you for having me. Before I start, let me just quickly tell you who I'm associated with. In the first instance, I'm a professor at the University of Cambridge in chemical engineering. My research group there is the COMO group, but the last 10 years I've been the director of CARES. This is the Cambridge Research Lab in Singapore. But I'm also an entrepreneur. Yeah, I have co-founded two companies, CMCL, this Computation Modeling Cambridge Limited, and Computation Modeling Pirmasens GmbH in Germany. And all of these groups have contributed to what you're going to see.
Markus, sorry to interrupt. There's a few people, and you sound a little bit away, far away from the microphone. I just was when you face in the other direction, we can hear you better, if that's okay.
In this direction?
Yes, that's it. Perfect. Yeah. Thank you.
This is because I'm not using the microphone of the headset because people have complained in the past. Okay, let me.
Yeah, it's better now when you're facing the screen like that. Thank you. Sorry.
Let me do this. No problem. No problem. I want you to hear me. Right. Okay. Good. Right. So as I said, I'm associated with several groups, and what I'm trying to convey in this talk that what we do is beyond connected digital twins, sort of a different philosophy. And this is why we called it the world avatar, as we are attempting to create a knowledge representation of the world rather than just a platform. Okay, so let me get on with it. Okay. In theory, there should be next slide. Ah, yeah. Okay. So we have a nice logo, as you can see, and there's a website where you can obtain information, World Avatar IO. And so what is this all about? In the first instance, it's a bit abstract. Okay, so it's a change in perspective. So at the moment, most of the stuff we do, a human has a goal, okay, and knows how. The standard example I normally say at this is, okay, when I come home, yeah, and my mom sees me, and then she has the goal, yeah, make Markus happy. I better bake a cake, and then she goes and buys the stuff and makes a cake, put it in the oven, and there would be this robot here, the oven, yeah, and a little later, the cake comes out and I'm happy. Okay. Now, in future, we want to take the avatar an important role, the important role of the how. Okay, so the human supplies the goal. In this case, baking a cake. But if I'm involved in that process, then I don't know how to do it. And sort of a hybrid version of it, I go and get a recipe book or Google a recipe. And then I follow that recipe almost like an algorithm. And then a little later, there may be a cake. Of course, not as good as my mom's, but there is a cake. Okay. And now the idea is that this knowledge model needs to be formalized and be available to humans, but also to machines. So basically having a consolidated format in how to represent knowledge. But of course, the world is changing. And in the first instance, in order to be able to do that, you have to be able, in a knowledge model, to go from a goal to a sub-goal to a smaller goal and so on. Okay, so you need to have some sort of derivation of sub-goals. And secondly, because the world is changing, you need to make sure that your knowledge of the world is up to date, okay? And for this, we have invented something that's called the Derived Information Framework. So how do we do this? We use ontologies to express conceptual models of particular domains. We use ontology to represent data in logical knowledge graphs. And that has the advantage that is distributed over the internet using semantic web technology, and that corresponds to the FAIR principles that are well known. Okay. Now this graph has the advantage that it allows, with the information derivation framework, that information can cascade through the knowledge graph. So imagine you have an object, this object is a market value, then of course the market value is linked to a property, and if the property, say, is flooded, we can then directly get the impact. So if we want to know the impact, then we can reverse this trajectory and make sure that we are always getting the most accurate piece of information. Now the world avatar is sort of so everything is meant to be a one entry point system that connects everything, literally, and I will see in a minute what I mean, because it has agents that are part of the world avatar and are also ontologically represented. You can use it to control, and I will show an example. Of course, you then, if you have that, you can query, and as earlier said, you can use it to imagine, and that's basically another word for scenario analysis. Now, because it's extremely open, you know, the world is not the world as in planet Earth. The world is the set of all possible concepts that are thinkable. Okay, we can start at any scale, and that's what we did. So what you see here, this molecular scale, so we represent molecules at quantum chemistry on molecular level, and we are able to automatically derive potential energy surfaces. Not sure that means much to many of you, but this is where it starts. We have also used it to create chemical materials of specific structures. And what you see here are networks. Some of you may have heard of MOFs, metal organic frameworks, or metal organic polyhedrals. These are specific molecules that are very useful in catalysis. And if you use your washing powder, you may have been familiar with zeolites, and we have also represented zeolite structures. So all of these things sort of are connected, and there is a central entry point. I told you that we can, that this whole thing is dynamic. So we have connected laboratory robots in Singapore and Cambridge that conduct experiment independently. And I've just mentioned this, we have used this metal organic polyhedrals, deconstructed this as Lego, and were able to use our knowledge representation of the fragments to create structures that were unknown before. So this is a different route than just pure machine learning. And then, of course, you can then go further up and go on the scale of buildings. And what you see here is a 3D representation. And what's behind this visualization is a complete representation of the building information model and the building management system and the assets in the laboratory. So, for example, I've just told you about our robot. This is the robot that in its own right, in the individual pieces of that robot, is instantiated. These machines, the instances talk to one another, both in Singapore and with the one in Cambridge. And the agents conduct by, you know, the goal is find a better solvent, and then the whole machine goes and tries to do this, okay? But as I said, we have also the asset management in the building information system, and the building management system. We at the moment control the fume. I think at that point, I don't know, I'll show that later. I've told you about the 3D representation. What you now see is LOD2 mixed with building information model representation in one visualization. And this is a house in Pirmasens. In fact, this is my my home where I live when I'm in Germany. For this house, we have then various representation. I will explain this later. In Singapore, one of the big challenges is city planning, and at the moment this is a very tedious process. You have a lot of PDF documents, and you have geographic information software and some visualizations, and so say if you want to open a shop, or then say you want to have a beauty shop, a beauty salon, and then the question is where can you put it, and that has to follow certain regulations. And we have basically what you saw earlier translated in what we call Augmented Singapore as part of the World Avatar, and you see just a little selection. So here you see the programmatic plot finder. That is an option for people to find these right plots. Okay, here there's a block area. This is a park. Okay, subject to evaluation and localized urban design guidelines. We have representation of the vegetation. This is a heritage tree, and 3D of buildings. And just to show you that this is so this is the actual website where you can see the whole of Singapore. Takes a little while because there are quite a few hundreds of thousands of buildings, and here you can select your Landlust type. So for example, business park or business, and then you can select plot area, and it will then show you where this is. As I mentioned earlier, here are the trees, just to give you an idea. But to go back to we also have the ability to look at the emissions from ship. This is live now, okay? You can get this specific ship position, and depending on their speed, we can calculate or estimate emissions, and then we can place virtual sensors, and that give us a timeline. You can see the important NOx, SOx, and particulate emissions at a specific position, and look at how this changes over time. There are, of course, peaks depending on whether the ships move their position, but it's not just here. You can, this is Jurong Island in Singapore. You can have that everywhere. Right, so back to the talk. Okay, so I've just showed this to you. This is this dispersion of the emissions. And once you have that, you can then instantiate this on mobile phones, and you basically can then augment the sensor data that you get from mobile phone directly. This is the orange bit, and so you get the green bit, that is APIs from elsewhere, and the blue bits are basically the results from the World Avatar simulation. That is all consolidated into one app in your phone, and you can walk then along this trajectory. And as you walk along, okay, you may then enter a bloom of emissions, and then you know, the phone may beep and say, yeah, you better go back, and so on. But in Singapore, we have also moved on to look at the NTU campus. This is where I live at the moment. In particular, this is where I'm sitting here, this building I'm sitting. And here we have also incorporated the class schedules in the different buildings. And also weather forecast. And let me just show this to you. Yeah, here you can see it. So you have the colors correspond to different building usages. We have the surface water sensors in here, and also information about the electric grid, live information. And what you can see here that we've been integrating, this is not BIM, this is now LOD3 building. So we have different ways of displaying the properties of the building. But for us, this is the visualization. You could think of these visualizations as a window to a much higher dimensional space. So for this building, we not only have LOD3, we also have a LOD2 representation and potentially a BIM representation, all in one instance that describes the building. And of course, also with all the other aspects of that building. Of course, not complete. So what we do, well, otherwise is always incomplete, because you can think always of something else that you can add, but because of this graph nature, you can then easily add it. So this is an example of our lab. Okay, here, this is the BIM representation of the building. And if I click here, it's a bit slow because it's enormous. These are enormous data. So this needs a faster computer than our laptop. You can see here the different levels of the buildings. So far, we have, in that detail, we have only level 7 because this is our lab. Okay, hang on. And this is the robot that I've been talking about earlier. Okay, back to this. And this. Okay, so now you see with this, because everything is dynamic and can sort of interact, we are now working with the company BNL to optimize the waste collection and automate ESG reporting for specific customers. So here you would lead the track load, weekday, season time, client type. So we've also instantiated people, weather data, live traffic, and with that you get basically recommendation on how to collect the bin, and basically also the administration is now much easier. So now I've already mentioned it earlier, this Pirmasens, it's my hometown. It's beautiful. It's in southwest of Germany. So this is a little tourist advertisement. Yeah. And this is what it is in a Mapbox 2D representation. You can see the buildings with different colors. The colors correspond to different hues, and the colored surfaces corresponds to isochrones. And I have already mentioned it or showed it before, this BIM representation of what we call the House 45. And we have put a sensor there, and with this sensor we've been calculating a scenario in which we use photovoltaic PV generators, and we're able then to look at this timeline. We have also been using a tool that's called the City Energy Analyst to get the overall demand of electricity, power, heat for the city, which will come in a minute. And here what you see is we have, because I'm from that region, I got stuck during COVID. I talked to the mayor and the guy who runs the utilities, and then we basically instantiated the district heating system, including 3 boilers, a gas turbine that can co-generate electricity, the energy from waste platform, and then the distribution network. And we've integrated gas price, CO2 price, electricity spot price, temperature, heat demand that comes from our estimates, flow temperature and return temperatures. And with that, you can basically see a live representation of the dashboard. And we were also able to use these isochrones. This is coverage of school within 15 minutes of walking in Pirmasens. So we integrated population data from Meta, and we're able to say, okay, how many children live within 15 minutes from any school, and help the people, the planners in Pirmasens, to work towards this 15-minute city concept. And you may have heard Amit Behave yesterday. He was talking about Credo. And so my company, CMCL, was involved in this project, and we actually used the World Avatar concepts to connect these infrastructures. I don't want to say anything in detail because Amit talked about it. But then on top of this, we have augmented people, city usage, and so on. And so this is just a figure for Credo. But what I would like to do now is to show you. Okay, this is by the way, this is the building management system of our building. So we have instantiated the building management system, and we are able to change set points and send emails to people who didn't close their fume hood. So you can go here and look at the fume hood, say fume hood 11, and then you should see somewhere down the line, Cunningham hood, walk-in fume hood, the opening of that fume hood. I'm getting a bit lost. I leave this to your imagination for a moment. And let me just move this thing a little bit over here. And this was Pirmasens. Okay, I already told you about the district heat plant. You can see this here. And the system. So this is currently, this is historical data from 2020, where we got an hourly resolution of the overall system, and we developed a model predictive control that underlies and controls the whole thing. At the moment, the gas turbine is active, partly because of the electricity price, because although the operational cost for the gas turbine is higher, the price of electricity makes it beneficial to Stadtwerke to operate it. Here, so this, and yeah, and of course, then we can calculate. This is the municipal heat plant, and here we can then look at the emissions that come out with different timestamps over different time, and you can sort of see how they influence the environment. And we have here virtual sensors, just like in Marina Bay Sands, and are able to then look at PM10, PM2.5, and NOx emission. This is in particular interesting down here because this is the power plant, the combined heat power plant. And this is interestingly very close to the hospital. This is the hospital. This is the power plant. And if you click here, you can see the live data, hopefully, maybe. You can see here the gas turbine and the heating boiler and so on. So heating boiler 6 is switched off. So this is the Pirmasens, apart from the Pirmasens representation, and what I would like to show you now is basically the King's Lynn Cambridge thing. So what you see here, we have instantiated all live sensors of the UK, and for the cities Ely, Wisbech, King's Lynn, and Cambridge, we have started to resolve more data, include more data. And what you see here, these are the food ratings of the different restaurants as well. You can then get here and you see the restaurant name and the corresponding food rating. And here, this is the roadside measurement of nitrogen oxide. And of course, with that, you can, of course, directly communicate with your mobile phone. Okay. So I'm like, now I've shown you a number of things. But we can also do this for other countries. And so we've just started to look at the data that is provided by Chile. I have a poster from Chile, and she speaks Spanish and knows a lot about Chile. And Chile is an interesting country because they hope to be what Saudi Arabia is for crude oil. They want to be the Saudi Arabia of hydrogen. And the reason for that is the strong winds and high solar potential. And they are in a very good position to generate electricity, and the surplus is then hopefully going to electrolyzers, which then turn hydrogen into, which turn electricity into hydrogen. And maybe here a quick look at Chile. Chile. Yeah, here's Chile. This is very, very rich. I move out so that you get an idea. So I switched everything on. So you see a lot of clutter. And the main reason why I do this is to give you an idea of how rich the data situation already is in Chile. And of course, what we haven't ontologized this yet, so this is to come. So we just use the World Avatar Visualization Framework for 2D representation to show this data. Okay, back to the talk. I need to finish in a minute. But we have also done scenario analysis. And this is the Mekai calculator, where we basically look into different scenarios towards a carbon-free Singapore. And that is fed, at least partly, as a hybrid solution where we get all the data from World Avatar. We can, and the rest is classical Excel spreadsheet. So we hope to move away from it towards a full integrated scenario analysis for carbon zero. Okay, so just in summary, we can do this in any location. We've done it in Singapore, Germany, UK, and Chile, but we can do it for Australia because it's a World Avatar, right? And we created a number of interfaces. So I showed you the 2D Mapbox type, the cesium, full BIM GIS, integrated representation, and we've developed various apps and dashboards to see the live data and also to interact with a citizen. And finally, I would like to show you, we have developed Marie. Yeah? Marie is a chatbot, just like ChatGPT, except that it doesn't hallucinate. It can answer questions like how many hydrogen bond acceptors does water have, and what is the boiling point, and then you get an answer from the knowledge graph, and at the same time you get here in this area you get. Can you still see my screen?
Yep.
Okay, you get here just a human answer, and then one more thing. This is Zaha. I'm not sure whether you know Zaha Hadid. This is a famous architecture, and so we have experimented with here a chatbot, so you can ask for King's Lynn what are the 3 dominant usage types in King's Lynn, and then it would go and query the knowledge graph and tell you, okay, single residential, 13,000, multi-residential, and so on. And you can ask many more questions. about energy ratings and so on. And now I have already, I think, overstayed my welcome. And with this is our first step towards full VR experiments for our lab. I want to close this talk, and if you want to have a question, then I'm happy to do that. I can only say, if you're interested in our work, then please get in touch. Markus Kraft, just email me, and yeah, I'm happy to collaborate or to implement.